All right, so at first we're gonna talk about what is inverse derivative, but before we talk about inverse derivative, we got to talk about inverse functions. Um, so inverse, I'm gonna show you inverse. Okay, so those inverse functions. And I'm gonna lead to inverse derivative. So the whole thing that here we're going to talk about inverse function is not that important. It's not going to be on the test, but I want to teach all the background information first before I build in the inverse derivative. Okay, so what we're going to do is we're going to have f of x. And this f of x is not any type of f of x. We're going to just name a function. I'm going to name this, I'm going to name, I don't know. What's a good function? 2x over 5x minus 7, something like this. Okay, so I'm going to show you how to find inverse functions first. Do you guys remember how to find inverse functions? How? Switch x and y, good. But there's no x and y here, but so you had to convert this f of x to y first. Does that make sense? And then you switch. So x, everywhere you have y, you place x. And there's a 2y over 5y minus 7. And what do you do next? Solve for y. Good. Yeah. So solve for y, you multiply both sides by 5y minus 7. So it'd be 5y minus 7 is equal to 2y. And there's a 5xy minus 7x is equal to 2y. And you're going to get all the y together. So it'd be 5xy minus 2y equal to 7x. And then y is equal to, y is a 5x minus 2 of 7x. And y equal to 7x over 5x minus 2. So you're going to look at this function, you're like, wait, they look almost the same, but they are not. So we're going to call this as f inverse of x. Now be careful how I read them. Now I'm teaching you a pre-cal here. This should read as f inverse of x. F inverse of x. Now I always joke around. If you know me, I'm not a very serious person. I tease you, I make fun of you, I roast you. That's just how I am. But I really told students, I says, if you ever say if you really want to piss me off, you're gonna say f negative 1 of x, and that's how you piss me off. I will kick you. So literally, I will come by and I'll kick you. Yeah. And I'll kick you so where nobody can see it, so there's no witness. So, huh? I trust me. I know what a camera angle is. Okay. So, f inverse of x. So why people say f negative 1 of x piss me off so much? Because people say f negative 1 of x, they think that is 1 over f of x. Because the negative 1 power, they say, oh yeah, that's just a power. And that's going to be negative 1, so that's going to be like this. But this is not true. Not true. Not true at all. Do not ever do that. Yes. Exactly. So you'll come up a very good idea. Remember that this part is not going to be a good idea. So what you can do is if you want a 1 over f of x, you're going to write down as f of x to the -1 power, then that's 1 over f of x. This is true. So this is true statement. This is bad. No, but just notice the difference. Now, you have to read them correctly. A lot of time, like math teacher doesn't teach how to read. It's kind of important. Like if you don't read it correctly, you don't register it correctly. In this case, is a perfect example. Are we okay? Yes. Okay, so I'm going to graph those both functions. So the both function is, I don't know, can somebody tell me the function?
X equals 2x over 5x minus 7.
5x minus 7. And what's the inverse function?
5x.
5x
Minus 2.
minus 2. You see the blue line and the red line, right? And then what happened is we're going to do a y equal to x. And what do you see? You see a symmetry. They are symmetry, inverse function and the original function, they are symmetry to y equal to x. Y equal to x is the symmetry line. And that's very, very important. Not only I want to show you important is this, I want to show you something right here. So I'm going to plug in a random value here, and I'm going to show you what happened. If I says, let's plug in something, I can get an integer. So let's plug in some, so let's plug in something that probably not going to get integer, but let's just say if I have, let's plug in a value, let's say plug in 3, nope. What am I going to plug in? That says, I don't know. Let's plug in 2. Let's plug in 2. Okay, 2, I'm going to get 4 over 3, right? Do you see that? 1.333 is 4 over 3, right? Mm-hmm. Now, I'm going to go to the inverse function. I'm going to plug in 4 over 3. That becomes 2. And we don't need to worry about anything else. Anything else is not important. We just need to know one coordinate because this applies to all the coordinates. This is the main idea of the inverse function. They switch. You switch x and y. Of course, their x and y coordinate, they swap each other. Does that make sense? Okay. Not only that, I'm going to show you on the original functions here. Original functions here, it's going to be, oops, my bad. It's going to be strictly decreasing or strictly increasing. So in order for you to have inverse, and you're going to have to know this word mean. I might test you this word. I don't know. This word says monotonic. And that's a very, very important word. Monotonic functions. What do I mean by monotonic function? Well, if some function is monotonic, that means what? Did we mention this before? I think I did. You guys don't remember it. Strictly increasing or decreasing. So the function had to keep on going up. It cannot go up and come back down. It cannot be like a parabola. A parabola is not monotonic because it goes down and up. That function cannot have an inverse until you do a restriction. I'm going to say again. If it's going down and going up, you have to cut the function in such a way that it's only going up. So that means in parabola, you have to cut a parabola to half in order to have an inverse. That's the first thing. Second things, in Shaparo's class also talk about it must pass horizontal line tests. Do you guys remember that? And if you don't have Chaparral, then you probably don't remember it. But it's not vertical line test. But you think about it. A parabola. Can parabola pass horizontal line tests? No, because you're going to intersect 2 points, right? So you cannot have inverse functions of a parabola. You can cut the function to half, then you can have the inverse. Okay, second thing. Result of inverse function, it is a few. One is x and y coordinate. Swap. So x and y switch, right? If they switch, that's going to be important. Second thing that you're going to see is the symmetry to y equal to x. Now, the third thing, I don't usually mention this, but this one's f inverse of f of x is always equal to x. Or f of f inverse of x is equal to x if they are inverse to each other. So if they composite each other, it will result with x. So think about inverse is like a machine. No, think about function as a machine, right? So I'm giving this analogy to a very young kid. So for example, a function is a machine. Y equal to 2x plus 5. And that is the function. Now, when x equal to 1, 2x plus 5, then it's going to be 7. So if you give it input of 1, then output is going to be 7. Are we okay? Now, the inverse function is like an anti-machine, right? What I mean by anti-machine is like this. So like if a function is a slicer, okay, it's a function, it's a slicer. So if you take any fruit in there, they will just slice for you. That's the function of the machine. That's the machine functions. Now, this anti-machine is going to be weird. Is anytime you give an apple slice, it go back to apple. But the function is you give an apple, you get apple slice. But this anti-function is going to be apple slice, they give you apple. So they just move it backwards. And that's the idea of inverse function. So if I put in the x on original function and then put it back inverse function, so if I put an apple into apple slicer, then it's going to become apple slice. But if I put the same product back to apple slicer, anti-machine, then it's going back to apple. That's pretty much what the third statement tells me. So this is the 1, 2, 3 here. So that's the idea of inverse function. Now, and we're going to mention one more things too. In order to have inverse function, the domain and range also switch. Okay, domain and range also switch. So domain of function and range of function, they also switch. And we're going to tell you that, for example. So I'm going to show you an example of a function. And this function, you should be very easy to find the inverse. Okay, so now we're going to talk about, is that okay? Can I move on? Am I going too fast? No? Okay. So now this is the part you have to pay attention now. So if I have an f of x equal to square root of x minus 4, can you find the inverse function? What's the inverse function?
It's just x squared plus 4.
X squared plus 4, thank you. Do you guys remember the graph of this? The graph of this, it should move 4 units to the right and looks kind of like eyebrow. Are we okay? Let's do a table chart. Let's compare the table value, and I'm going to show you the x and y swap. And that's a very important concept. So this is going to be f of x. What's the first value I can plug in here? The x. Why 4, not 0? Good. So 4. What happens if you plug in 4? 0. And what's the next value you can plug in? 5, right? Because you can square root 1. Square root 1 is going to be what? 1. What's the next value? 8?
Yeah.
That's going to be 2. Does that make sense? Am I going too fast? 13, 3, right? Now, this one I'm going to draw a little bit this way. There was a reason for that. So it's going to be x squared plus 4. It's going to be like this. And it's like this. And it's like this. And it's like this. Oops, my bad. So the function is like this. So this is f inverse of x. Does that make sense? And I'm going to put in the same graph of this one. So this one is this. This origin of f of x. Are we okay here so far? No confusing, right? And I'm going to put here, we're going to do x, y here. I should do this as red. Sorry, that was my bad judgment. So I should do this as red and the other one's blue. Red. And this one should be blue. And then that way you can see the difference. And this one should be blue. So if I do x and y, what will happen? Well, it turns out the value switch, right? If I plug in 4, wait, sorry, this is inverse. I don't want to plug in 4, I want to plug in 0. What happens if I plug in 0? You get 4. What happens if you plug in 1? What happens if you plug in 2? 3 and 13. Do you see this switch? This is still idea of inverse function. They're not derivative yet. Okay, are we okay here? So we did it on this graph, and we show you the blue line and red line. Yes. That's a great question. It turns out, remember domain range switch, right? So let's look at the domain of the red one. Domain is going to go from 0 to infinity. Does that make sense? Oh, no, sorry, not 0 to infinity, 4 to infinity. Does that make sense? And range is going to be what? 0 to infinity, right? Now, what happened with the blue one? Domain is going to switch, which is what? 0 to infinity? And range is going to be what? 4 to infinity. Do you see it automatically restrict them? Because original functions restrict, the other side is also switch. But if you start at a parabola, which is you start as x squared plus 4, then you have to restrict it first to have inverse. You can restrict the right side or left side to have inverse to the other side. Very good question. Yes.
How did you get the inverse?
That's what I did before. I'm going to show you how to do that. So I convert it to y. I switch. I square both sides. And I change to that. Does that make sense? So that's how I get the inverse function. So we're going to write this inverse function as this, right? Okay, so that's very important. Now we're going to compare the derivative. Okay, we're going to compare the derivative. So we're going to take this red function, we're going to take a derivative. What happens if I take a derivative? Well, derivative is going to be, this one is equal to x minus 4 to the half. So if I take a derivative, it's going to be x minus 4 to the negative half. Does that make sense? Does that make sense? And if I take a derivative of this, I'm going to take an inverse derivative of the derivative function. So that's a derivative function prime of x is equal to 2x. So what I'm going to do is I'm going to plug in 8. What happens if I plug in 8? 2 square root of 8 minus 4 is equal to what? 1 over 2 times 2, right? Is equal to 1 over 4. Does that make sense? Sorry, that should be red functions. So let me do that again. I'm going to do that in red. So f, that's not red, dumbass. F, if I plug in 8, what will happen? 1 over 2 square root 8 minus 4, right? That's equal to 1 over 2 times 2. That's equal to 1 over 4. Does that make sense? Now I'm going to plug in f prime. Well, instead of plugging 8, I'm going to plug in 2. So 2 times 2 is equal to 4. Do you see the relationship? And if you don't, I'm going to do one more. Let's say 13. So 1 over 2 times square root 13 minus 4. That's equal to 6. And the f inverse of 3 is 2 times 3 is equal to 6. Do you see that? And all this should be blue. Let me do that in blue. So that way you see it. F prime of 2 is equal to F prime inverse, F prime of 2, that's equal to 2 times 2, that's equal to 4. F prime of 3, that's equal to 2 times 3, that's equal to 6. So it went changed here and changed here. What do you see that relationship? They're just reciprocal, right? So due to this, the most important part of the lessons right here is the formulas. You can choose to memorize it or you can choose to understand it. So I choose to make sure I see this. So what I'm going to do is I'm going to take this and we're going to say there was an f of x and g of x is equal to f inverse of x. Does that make sense? G of x is just inverse of x. Are we okay here? So I can write down f inverse of x. So the formula, I'm going to give it to you. It's going to be something very helpful. And this is something very helpful here is you can memorize the formula, but you have to understand how to use them. This, the formula is going to be this. I'm going to give you 2 different versions of it. So g prime of x equal to 1 over f prime of g of x. Or I can do f inverse of prime of x, which is, that's so much harder to write, is equal to 1 over f prime of f inverse of x. Now, some people understand this one better. Either one is the same thing. It just I'm changing g of x to f inverse of x, so that's understandable. So this is the inverse derivative. Now, due to the experiment that we did, we understand always going to be reciprocal to each other, but x and y value are going to switch. Are we okay here? Now, what we're going to do is we're going to pull out I bring a group of students went to math competitions, and this is a very common math competition question. And I really wish some of you guys would be able to join us next time. But this is a question that is always on it. So we're going to go to for.ml. And I'm going to take a picture of this questions. And I'm going to show you. Oh, no, I'm going to give you the questions here. And I'm going to show you that question. I'm sorry. I'm going to do this first. Is tomorrow you're going to have, Thursday, you're going to have this question. So it starts with this question. They say, hey, I have f of x is equal to x cubed plus 2x minus 1. And the question is going to say, can you find f inverse prime at 2? F inverse prime at 2. They didn't want to give you f prime at 2. They want f inverse prime at 2. Now pay attention. I write down something. This will help me, at least for people like me. I'm not very smart. Yeah, you probably think I am, but I'm not very smart. This is what I did in high school. I write down f of x, and I write down inverse of x. I can write down g of x if I want to. And I'm going to have an x and y input-output situations. This 2 is going to the inverse. Does that make sense? Does this make sense or no? Is okay? Are we okay here? Because we plug in the prime, right? We plug in 2, right? So can I plug in 2 here? Are we okay here? Now, what's cool thing is remember that value swap. Does that make sense? That means original function y values 2. Now, if original function y value 2, can I take this and can I say 2 equal to x cubed plus 2x minus 1? Does that make sense? I put in a y as I put in the 2 as a y value, and I solve for it. I solve for 0 equal to x cubed plus 2x minus 3. Does that make sense? It turns out this case is not factorable. So if something not factorable, which has happened, then you're going to take a random guess. You're going to guess a number that's going to fit in here. This is going to be a very easy number. You know, I'm thinking about easy number like -1, 0, 1, 2, -2. Which number can you going to plug in here? So you're going to guess here, right? Now, does all the time you need to guess? No. Sometimes you can solve. Sometimes it could be x squared minus 4. And x equal to positive -2. So can you guess a number that can fit in the situations? What number you can guess? That's not factorable. Which number I want to guess? Yes. Just 1. 1 plus 2 minus 3 equal to 0. Got it? Does that make sense? So that means this is 1. If that's 1, that means this is 1, right? So this led to this. Now you're gonna be like, Mr. Ye, can I just find the inverse function of this one? But the problem is you cannot find inverse. There's issue to finding inverse. Issue finding inverse. And if I find the inverse, can I take a derivative? Yeah, of course I can, right? The other function work, this function doesn't work. You're gonna find out it's gonna be y equal to x cubed plus 2x minus 1, x equal to y to the cube plus 2y minus 1. And you move the 1 over, so it'll be y cubed plus 2y equal to x plus 1. And there is stuck. You are stuck there because you cannot isolate the y. So there's no way for you to isolate. So we're going to find a tricky way to find the solutions. Now we're going to use these formulas. I can use this one or this one. We wanted this, right? F inverse, so I'm going to use the right one. Prime at 2. Does that make sense? That means 1 over f prime. Well, we got to figure out what f prime of x first. F prime at f inverse of 2. F inverse of 2 is what? Yeah. Is equal to 1 over f prime at 1. Does that make sense? And which is equal to 1 over, well, I'm just going to take a derivative. So if I take a derivative, f prime of x, I can do that really fast. 3x squared plus 2. And I'm going to plug in 1, so it's going to be 3 times 1 squared plus 2. That's equal to 1 over 5. I just find the derivative of inverse function without finding the inverse. Now, a lot of questions going to be like this. We're going to give you some AP style question. We're going to give you some normal question. So now I'm going to give you a computation questions. It looks almost like this. You thought computation, math computation is really hard, but it's not. Both. But it's not hard. The math computation that you think is hard, but it's not. Let's check the calculus, and let's get a test. And we're going to get a test here, and we're going to look at exactly question 15. Now, the AP exam question, they give you the value too. You just had to find the thing. So we're going to look at this question 15 right here. Do you guys see it? Question 15. Now, all other questions hard. This question actually is doable. It's very fast too. And actually you can do it without lifting the finger. So how many percentage of this time the test question on the test? On AP exam, around 40% on MCQ. So and this is almost the same question. And by understanding this one question, you already can score 4 points on a math competition. That means you're not going to rank last. And you probably can solve first too, so you probably get 12 points. That makes you rank pretty good. And you don't have to lift a pencil to do this one, really. This is almost exactly the same question. So math computation, this is almost 100% of the time they will ask inverse derivative. For a AP exam, probably 40%. But if it's 40%, this is a good question. The long division one, probably 10%. So the answer is 1 over 5. 1 over 5. You're going to set 4 equal to x cubed plus 3x. and then you're gonna guess a number that will work. X is equal to 1. Then you're gonna take a derivative, like h of x, which is h prime of x, which is 2x plus 3. And you plug in 1, it's 5, so it'll be 1 over 5. Yeah, hold on a second. Let me give it back now. Yeah, I'm sorry, I did. Um, okay, so I got here. And then all this question, you still have to study for it because I might give you a surprise, put it on it again. Yeah, make sure you understand it. Like I might put it on a test. Steph? Okay. Caroline? Trevor? Caroline. Sarah Jung? Laurel? You need to come back work on this one. Ethan? You need to come back to work on this one too. Nicholas? You need to come back to work on this one. Katie Cohen? What did you mess up? Oh my god, you messed up calculation. Ugh.
Darn it.
You know how to add. Sarah Z? You messed up calculation too. Dashin? Dashin's not here today, right? Kevin? And Sydney? Good job, Will. Hi. How are you? Huh? No, do it here. Huh? That's fine.